Good morning, everyone. We'll go ahead and get started. Welcome and thank you for joining us this morning. My name is Eric Ha, and I'll be your moderator for this webinar today. If you have not given your poll question answers, please do so now, and we will review them after the presentation. I will also have a Q&A session at the end of the presentation, so please feel free to submit your questions throughout the webinar, either through the Q&A box or just a regular chat box is fine too. We value all feedbacks from industry professionals as yourselves to help us learn and better serve you in the future. Our presenters today are Ivan Moen of Comitt Well Solutions and Mark Hobart of Ranger Energy Services. Ivan is the co-founder and director of business development at Comitt. He has 14 years of experience in the oil and gas industry, most of which have been developing and commercializing new downhole technologies. He holds a bachelor's degree in petroleum engineering from the University of Stavanger and an MBA from Rice University. Mark currently serves as the Vice President of Business Development, Marketing, and Technology at Ranger Energy Services. Prior to joining Ranger, he held several executive leadership roles with public and private upstream, midstream, and downstream service companies. He also held multiple sales, marketing, engineering, and operational roles with Baker Hughes and Cameron after beginning his career as a field engineer with Schlumberger. He holds a bachelor's degree in petroleum engineering from Louisiana State University and an executive MBA from Houston Baptist University. And with this introduction, I'll hand it over to you, Ivan.
Thank you for that, Eric. And also thank you to everyone who have joined us for the webinar today. This is the third webinar we're doing in 2021. And the topic we're doing today is one we've been wanting to discuss for quite a while. The previous webinars we did this year dealt kind of large with results and best practices from single well applications. And we kind of went through case studies and stuff on how we have used our Comitt Excite system to achieve production uplifts and good returns when the right candidate wells are restimulated. So we felt the next logical step would be to take a look at how we can implement this at a larger scale. And to set the stage for that a little bit, over the past decade or so, our industry has seen a tremendous amount of improvement when it comes to efficiency gains in drilling and completion operations. Less than a decade ago, we easily spent 45 to 60 days drilling a well. And today, some operators are drilling a horizontal well in a little over a week. And a similar story is seen on the completion side, where we at 10 years ago, so maybe less than 10 years ago, we're pumping 3 or 4 stages per day with a frac fleet. But with the development of technology and zipper fracking and these things, we're now pumping 10 to 12 stages a day per fleet. So moving our industry from a development stage and over to a manufacturing stage has shown huge improvement when it comes to drilling and completion of new wells. And then as the industry, or the shale industry at least, is maturing, the question is then, can we use the same manufacturing style principles to realize larger returns and better wells when it comes to restimulating and refracturing existing wells? So this is the topic of today's discussion. And it's a topic we're very excited to discuss together with Mark here over at Ranger Energy Resources, because we think that combining downhole expertise and also with expertise in terms of the surface operations that are happening is very key to unlocking this potential. So in the presentation, we'll cover technology, we'll cover best practices when implementing large-scale restimulation programs, and also why it makes good economic sense to do so. And then at the end, we'll do Q&A. So please submit your questions throughout the presentation if you have any. So let's kick it off. Kind of the example we want to think about is, let's say we have a field with, say, about 300 producing wells, so we're looking to increase production at the field level. So out of the 300 producing wells, not all 300 may be good candidates for restimulation. So the first thing we want to do is to screen for the best candidates. At a high level, we want to look for wells that are in good rock, because as the saying goes, you can't make bad rock good. And this is really, it sounds mundane, but this is an important point, because early on, kind of in 2017, 2018 timeframe when we commercialized our Excite system, we were treating wells that very often had either been severely depleted, or it was wells that had never really panned out to begin with. And kind of surprise, the production uplift from those wells would not be what we had hoped for. And here's a couple of maybe example of candidates to not treat. And if we start out with the one on the left side, this is a vertical well where the production has declined to, at the end about 2 or 3 barrels a day. And so a restimulation of this well will probably give some uplift, but the big question is, will it be enough to create a good project? So if you go from 2 or 3 barrels a day up to 10 barrels a day, which will be almost early on in the cycle of lifetime of this well, then percentage-wise, that's a good uplift, but it's still just 6 or 7 barrels to pay for all the bills. So it may not be the best candidate to focus on. And similar thing on the right side here. This is a horizontal well. It's a 10,000-foot lateral that we took a look at for restimulation purposes, and it's a well that never really panned out to begin with. I mean, it came out at about 200 barrels a day, dropped off quite quickly, and from a restimulation point, you can restimulate this kind of a well too, and you're probably going to get some production uplift, but the potential may not really be here for a good project. So rather than spending money on these kinds of examples, focus is better spent on wells that are in good rock, where you still have some good bottom hole pressure, and where the production, for whatever reason, has fallen off the type curve. So as we discussed in the previous webinars this year, the original type curve of a well is a very good indicator for how much production uplift you can expect after a restimulation and what the decline will be after the treatment, as long as we can get the whole lateral treated. So here is a much better candidate well, where the production started out very good, and then as we kind of go out to about month 26 or so here, the production of this well falls off the type curve. So then we're at about 100 barrels a day, and then it falls off the type curve, and the well is at the end of here doing about 30 or 40 barrels a day. In this case, if you were to go restimulate, like I said, the type curve is a good indicator here. So you can expect a minimum to get back up to 100 barrels a day. And very likely you can add quite a bit to that as well and kind of accelerate production back and maybe get up in the 130, 150 barrels a day. And then where it levels off, it will follow the original forecast of the well back down. So we have a lot of data now showing exactly that, and these are the kinds of wells you would want to look for in your well or in your field, where you have you're in good rock, you have good production from the get-go. There's still plenty of upside potential left in the well, but for whatever reason is producing below the forecasted values. And kind of as I mentioned earlier too, I mean, we've kind of gone through our learning curve when it comes to picking candidates, and I think more than anything else, our clients have certainly gone through a learning curve when it comes to picking candidates. So here's if we kind of take the average production for the 6 months leading up to a restimulation, and the average production for the 6 months following a restimulation, and plotted out by year in terms of which year the well was treated. What we have here, I mean, this is the average before we do a restimulation. You do the treatment, and then the wells we treated in 2018 followed on average this curve, the ones in 2019 here and the ones in 2020. So the learning curve is there. Like I said early on, we treated a lot of wells that probably didn't need to be treated, and that's a little bit of the contributing factor to the lower 2018 uplift. But we keep learning in this, we keep getting better at this, and like I said, our clients more than anything else are really getting much better at picking good candidates, and that's really key to realizing a good economic return from restimulations, certainly at an individual level, but especially when you're looking at a large scale like we're talking about today. So this graph is one you'll see throughout the presentation, and it kind of shows, it indicates the production we're targeting at the field level before and after a restimulation campaign. And if we think about this as just going out and restimulating 100 wells, if we go out and do our proper candidate selection, you will add on to the you can add a good uplift, additional uplift to what you can already expect, and more than anything else, you're focusing your capital where you get by far the highest return. So in our example with 300 wells, and we said about 100 wells fit this profile, and we narrow that down, and once that we found the wells we want to focus on, we start moving into pre-job planning, and I will hand it over to Mark here to go through some of those steps.
Okay, thank you, Ivan. Appreciate it. So now that Ivan's discussed candidate selection, let's talk about some of the pre-job planning considerations for our restimulation program. Proper pre-job planning certainly can result in minimizing our operational risk, maximizing our efficiency, and our repeatability for a large-scale restim program. So when we're taking on a large program, obviously we've got several goals. One of our first and foremost is to maximize our safety performance and our efficiency out in the field. Second, we want to reduce our operational variability. We want to stick to our plan and tighten up the window of performance throughout the program. And then third, of course, we want to deliver meaningful production uplift. Prior to performing or planning an operation, one of the first things we'd like to do is to sit down, visit with the operator, and review previous stimulation treatments and their results. Take a look at the operational procedures, their stimulation treatment design, their planned cost versus actual, and of course the production uplift that resulted from the program. We can also perform pre-job torque and drag and hydraulics modeling to minimize our risk and ensure operational effectiveness. We certainly will design our operational procedures, our standard operating procedures, the stimulation plan, and our cost model to follow throughout the job and throughout the program. One of the key selection criteria is the crew. It's critical to select an appropriate crew for this type of a treatment. We're going to recommend operating on a 24-hour scale and basis. So it's really important to choose a completion crew who's got experience working in long lateral horizontal wellbores and working 24-hour operations. Here you can see one of our Ranger Elite completion crews. They've got our Ranger Readiness certification that includes advanced well control training and competency assurance. So they're properly prepared for this kind of an operation. And then we'd like to use a consistent crew or set of crews throughout the program so that we can implement continuous improvement from well to well. So a typical restimulation procedures includes mobbing in the equipment, rigging up our rig, ancillary equipment, nippling down the tree and BOP stack, removing the existing production tubing packer, ESP. Then we'd recommend making a wellbore cleanout trip to ensure that we can get down to bottom and treat all of the perf clusters in the horizontal. We'd pull out of the hole, then go in, perform our stimulation treatments, and then finally run back in with the ESP packer tubing, nipple down, BOP stack, nipple up the tree, rig down, and demob. So again, we'd like to plan for 24-hour operations so that we can prevent having to recirculate chemicals each morning, and also having the cost of chemicals to clean out any debris that might be strung out in the vertical section of the wellbore. We've got some surface equipment and downhole tool equipment considerations as well. And then after the job, prior to the next job, we can calibrate some of our pre-job torque and drag and hydraulics models to implement best practices and our lessons learned. So when planning the Restim project, we'd recommend running a torque and drag model. There we go. So we can import the wellbore survey from the operator, model the wellbore. Here we're looking at a 10,000 foot roughly vertical section and a 10,000 foot horizontal wellbore, where we're using a tapered work string to perform the operations. And the key things are, we want to make sure that we're not going to experience helical buckling in the heel section of the build section of the well, and that we've got enough weight to be able to push the string all the way to TD to be able to treat the lowest perforated interval. And then we also want to ensure that we're not going to exceed the torque rating of our work strings and our connections as we rotate pipe to get to bottom as well. So that's another critical consideration. We would also like to perform hydraulics modeling in addition to ensure that we've got adequate annular velocity to clean out the hole for effective hole cleaning. We want to make sure that we've got turbulent flow as well during the cleanout trip. And then another purpose is that we can optimize our surface hydraulic horsepower to make sure we've got the adequate surface horsepower, but not necessarily overkill for the operation for both the wellbore cleanout and the acid stimulation treatment. So assuming we're able to circulate and get returns, that'll help to optimize our performance. Both of these models can help us reduce potential downtime, reduce variability, and increase repeatability from well to well over the program, which is ideal we're looking for. So some of the equipment selections criteria that we'd like to take a look at. Working in this kind of a fairly deep, long lateral, we certainly need to have relatively high specification equipment, state-of-the-art, high-rated equipment. In here, we're taking a look at a rig that's got drawworks of 600 hydraulic horsepower. We've got 300,000 pounds lifting capacity so that we can handle a long work string. And we've got a tall mast height, 112 feet or taller, up to maybe 117 feet, so that we can work with doubles, tripping doubles, as well as working over a tall BOP stack. Based on our hydraulics modeling, we want to appropriately size the hydraulic horsepower and the pumps that we've got on location. We might need a 2,500 horsepower pump and maybe have 1,000 horsepower backup for circulating and hole cleaning. If there's some pressure on the well, we may need to employ a rig assist snubbing unit as well. Certainly want to have API certified BOP stacks. If they're 10K, they're going to have pretty tall BOP stacks. So we're going to need a pretty high pipe handler that can work over that BOP stack up to 40, 42 feet. We also want to have enough torque so that we can rotate the work string to bottom. So we'd like to have a power swivel with maximum torque capacity. And ideally a torque tube that ensures that we can transmit that torque through the work string all the way down to the bottom of the well. Can also incorporate a mixing plant for chemical introduction as well, and cuttings and fluid separation. And of course, all of this needs to be inspected prior to deployment, maintained properly throughout the program, so that we're going to minimize any unscheduled maintenance and NPT. And then next, we want to take a look at the downhole equipment that we're going to utilize.
Yeah, I'm happy to jump in on that. So this is the Comitt Excite system that we use to perform focus treatments, focus restimulations throughout the wellbore downhole. The tool is a downhole isolation tool that you convey on a tubing string. So you convey it on a stick pipe on the rig that Mark showed, and allows you to isolate or straddle, if you will, individual stages or even individual clusters downhole. So you have your two packers that isolate your perforations. Depending on how far apart the packer or how big of a zone you're looking to isolate, you can break the tool right here, put in space out joints, and you can space out the packers basically however far you want. So one thing we often hear is that our clients are concerned with running tools into a lateral, and especially concerned with running packer tools into a lateral. So before we developed the tool, we did a very thorough analysis of existing technology on the market to identify failure mechanisms of previous technology. And what we found is that most tools that historically had been mechanically activated systems. And what I mean by a mechanical system is they activate packers mechanically by moving the tubing string up and down usually also against an anchor section downhole, and you kind of lock or anchor yourself in place for each stage that you're trying to treat. So the issue here is that the moment you have any kind of sand or debris around your work string, you're not able to move the tubing string to transfer mechanical force down to the tool to operate it, and then you get stuck. So with this in mind, we developed the Excite system as a fully hydraulically activated system where you activate and deactivate the tool simply by pumping down the tubing string. So you pump to activate, you stop pumping to deactivate. So with that design, we have removed all the mechanical mechanisms that caused packer tools to get stuck in the past. And we've now done over 60 jobs and 800 stages with the tool. So I think from a track record standpoint, we're in a good place. And we also have now a solid method to selectively and also predictably place restimulation treatments throughout the well and make sure the whole lateral gets treated. So combining the proper job planning and preparation steps that Mark covered with the right equipment, both on surface and downhole, you can also make sure a more predictable operation, and you can ensure the whole well is treated, which ultimately results in better production again. So we keep adding on to our production uplift. Sorry, there we go. And then at the same time, our capital efficiency also continues to improve. Now, data is kind of a big thing these days, and data collection and data-driven decision-making is something we hear a lot, and that's used a lot throughout the industry and throughout all parts of our lives, and it's adding a lot of benefits currently. And so the question is, how can data help us also achieve further efficiency gains for restimulation programs? And I'll turn it back over to Mark to go through, to start at least going through some of this.
Thanks, Ivan. Absolutely. In addition to our pre-job planning during the job, we want to use data-driven solutions so that we can monitor our operations real time, regardless of where we're at. We can identify our baseline operational metrics. We can help determine the effectiveness of our acid stimulation treatment for each perf cluster. And then ultimately to enable continuous improvement from well to well and job to job. There we go. So we recommend using a digital operations toolkit, and our primary toolkit is called Ranger Live, which is a mobile suite of apps that we use to provide our operations teams all the tools that they need to perform safely and efficiently via a tablet on location. So this Ranger Live mobile platform includes a handful of apps currently. We've got on the left our EQHSE app, which enables us to operate safely. It gives our crew everything they need: their QHSE management system, standard operating procedures, their training documentation and records, their safety planning forms, observation tools. So it's all inclusive. The eDrive app for our DOT drivers provides their electronic logging device. And we also use it to monitor and improve driver behavior and scorecarding of their behavior. The EPMM app is our preventive maintenance management application. So we use that to track and monitor all of our equipment, all of our assets, to schedule our maintenance, plan our maintenance, and then document that maintenance as well. eTicket is our electronic ticketing application, which enables us to submit an electronic ticket to our customer, but it also is a valuable tool and it allows us to track our activities throughout the job. We're going to take a look at that in more detail. eRIGS is our Ranger information gathering system, which allows us to capture data on location and monitor it real time via a cloud portal or your smartphone, regardless of where you're at. So we're going to take a little deeper look at each of those two systems, the eTicket and eRIGS. So with eRIGS, we've got sensors on location that allow us to monitor some critical criteria from each piece of equipment in the operation. Again, we're monitoring and capturing data real time. So we've got sensors on the rig. We can capture and monitor hook load, string weight, block height, our depth, our tong torque. On the power swivel, we can capture our RPM and our torque. And then regarding pump in and return, we've got pressure, rate, and volume as well. These can be monitored on location in two different user interfaces, and they can be monitored via cloud portal as well as a smartphone app as well. So the objectives of using this system are certainly to benchmark our performance, to monitor real time so that you don't necessarily have to call the operation every day, every 6 hours, every 12 hours. We can use it to identify our best practices, implement operational improvement performance. And it gives us the opportunity to monitor operations through a control center, or our customers can monitor through Ranger Live customer portal as well. A unique feature of our eRIGS system is that it incorporates a dynamic reporting feature, and you can choose anywhere from a day, 24 hours, up to 28 days to view the data in and maybe perform a report. So a great use of this is each morning, most of our customers have a morning daily operational report. And if I were the engineer, I'd come in and I'd pull up the last 24-hour operations, take a quick look at a snapshot of what's transpired, what's happened, what have we done in the last 24 hours, and pull that report, print it off, take it to the meeting, or just report to the team. Another great use is for post-job reporting. So if the job took 4, 5, 6 days, we could produce a complete post-job report in one snapshot and close that project out. So it includes activity information, which is the color coding in the donut chart above and the timeline chart. Then below that, there's 3 graphs. One shows the weight, pressure, and depth. The middle chart shows our block position and our slip open and closed. And the bottom chart shows our pump pressure and our pump rate charts. At the bottom, it's difficult to see here, it's very compressed, but we also have the details that the rig operator has entered in terms of specific activities. So in addition to this real-time data monitoring, we also have our electronic ticketing activity reporting system. Now, this isn't real-time, but each day this gets entered into our database, and we have visibility to it every day. So we've got a set of predefined activities that our rig operators and our tool pushers can select from, and they tag that with a start and a stop time and then the activity. So now we can track and compare pretty much any rig or any operation or any well to look for baseline performance, outliers, and implement corrective actions. Here we're just showing a sample data set that could be used to improve performance. In the upper left-hand quadrant, we're just looking at activities. So we've got total jobs complete monthly and a cumulative jobs complete monthly. And then below that is a uptime percentage. So here we're running greater than 99% uptime across those months, and the time frame and the rigs that we're reporting on in this particular report. In the upper right-hand quadrant there, you can see average hours per well per month, also average cost per well per month, total hours for various job types per month, and then the downtime specifically. So what NPT did we experience for various reasons that we can further investigate and try to root out and prevent that NPT from reoccurring. The bottom right shows the average time or hours spent for each of the activity groups that they can choose from. There's about 25 different activity groups. We're seeing a fraction of them here. And then on the bottom left, this is where we can actually compare one rig against another, say over a 1 month time frame. And we can identify if one rig is taking considerably more amount of time than another to perform certain activities. Then we can investigate why that might be occurring, drill down and identify if there are any improvements that can be implemented here. So both of these systems can be utilized to conduct monthly, quarterly, periodic reviews of our large-scale restimulation project to implement a continuous improvement program and maximize our efficiency.
Yeah, so kind of switching to the downhole side of the data equation here, we collect data on every job that we do that we can use to further augment project economics and also augment improve the stimulation that we're doing on the well. So on the Excite system, we run downhole gauges both between the packers to record pressure data in the zone that's being treated, and then we run above and below the packers as well. And this gives great intel on a variety of issues downhole. One thing is the variance in breakdown pressure throughout the lateral, if we can see how much pressure is required to establish injection into each stage or into each cluster, and kind of how this changes. And with this data, we can then use it to find previously untreated rock within an already existing stage. And the other valuable piece of information is that it's regarding cross communication, because we can see which stages and which clusters that cross communicate behind pipe. So if you pump into one set of perforations and pressure comes in above or below you, and we can find which clusters and stages that are fully isolated from each other, where all the treatment we're pumping into the formation goes into the formation. So with this data, then we can also then identify refrac candidates. So you keep working through your inventory of wells and that you're restimulating. At the same time, you're mapping out each individual well for refrac purposes, and you find out which wells to refrac and also which part of the well you should focus on for the refrac. So you always focus where you get the highest returns. And here are some pressure signatures of previous treatments that we've done using the tool. The pressures you see here, they are all injection pressures, all the pressure, kind of breakdown pressure, or what it takes to establish injection into each stage. So look at the example up here, for instance, in the left corner. This is a 4-stage completion with 4 clusters per stage. In this well, we use the Excite system to isolate each individual cluster downhole, and then I restimulate at the cluster level with acid. And as you kind of see through here, there's a large degree of variability in the rock, not just at the stage level, but also in each individual cluster. With this data, you're able to find the clusters that were dominant and the clusters that were previously untreated on the original completion. So from a refrac standpoint, you want to focus on the kind of the high points up here, because this is rock that's previously untreated, and you can now tie this into the well with a refrac system. So the pressure gauge technology, that's something we now run as a standard on all the restimulation jobs. You know, like I said, kind of as you work through your inventory and you restimulate your candidates, you automatically also collect the downhole data, so you can map out each well for refrac, and then where to focus a future refrac treatment. So going back to our production chart, then adding the efficiencies that Mark went through from a continuous improvement that enables more wells to be treated per year. And also combining this with a refrac potential from targeted refracs, we were adding even further to the production upside, and also the capital efficiency continues to improve. So finally, let's take a closer look at the economics of our restimulation project, because that's ultimately what it all comes down to. And the concept I will use here is cumulative cost. And what I mean by that is the cost that, as it kind of keeps adding up throughout the lifespan of a project. And the example I'm going to use is to restimulate one well, an all-in cost of $300,000. And of course, the well cost, it will depend on a lot of things, geography and the size of the treatment and all these things. But I was going to use 300 grand as the average throughout the average budgeted restim cost throughout the rest of the presentation. And when most budgets are put together, we kind of tend to think about them as kind of a linear thing, right? I mean, one operation costs so much, the next one so much, the next one so much again, and we kind of add everything up like in this chart right here. But those of us who have been in the oil field for a while, we know that the planned cost is not always the actual cost, and this is usually due to variability in the time of each operational step. So an operation that I would plan to take 2 days ended up taking 3 or 4 days. And also, occurrence of unwanted events tends to happen in the oil field, and there seems to be, there's usually a pretty large cost in terms of mitigate and controlling these events as well. So this all kind of adds up to that the time in the oil field is rarely normally distributed, but it's rather kind of skewed heavily. And if an operation is planned to take 2 days, it could take maybe 1.5 days, but it's not going to take 2 hours. But on the flip side of that, it could take 10 days or it could take 15 days if things don't go as planned. And that's why job planning, like Mark covered too, becomes so important in terms of narrowing down the range to reduce the job variability for each operational step that we're taking, especially when we're considering a manufacturing type process. So let's look at a restimulation operation. For simplicity, I've kind of broken the operation into 4 main buckets. You pull your tubing and your artificial lift, you clean out the well, you stimulate the well, and then you run back in with your tubing and your artificial lift system. And from a risk mitigation standpoint, the clean out and the stimulation steps are the ones with by far the highest potential to reduce uncertainty and variability. And as we're going to see, these 2 steps are also closely related and correlated. So throughout the rest of the presentation, I will use what I call a on-paper example or an on-paper budget. And what I put up here is kind of the on-paper number of days that we're expecting each step to take for a total of, in this case, 6 days to re-stimulate one well. And when we're considering variability, we take that into the equation. Then we realize there could be a vast span in how long this job could take, and it could be far more than the 6 days that we had taken and we budgeted with, and the span is always skewed toward the high side. So what we have here, these are actual job time data numbers from our restimulations, and like we're seeing here, there is significant variability in job time for both the clean out and also the stimulation portion. So if we go back to our cumulative cost plot that I kind of started off this section with, and let's consider our kind of on paper budget. That's when we sit down, okay, this is what artificial cleanup's going to cost, stimulation, and so forth. This is kind of how it would add up throughout a project, up to about $300,000, which is my example here. But then if we take the low end here, we see there is very little downside or downward potential really on the cost side. But if we take the high ends, we see that we end up significantly higher than the original budget, and we're maybe even doubling the cost on that. And this is uncertainty, that we struggle to live with at when we just stimulate a single well, and it's uncertainty that we certainly cannot live with for a large project like we're discussing here. So let's go back to our job time data again. And an interesting thing to notice here is that our data show a very strong negative correlation between the number of days spent on the clean out and the number of days spent on the stimulation. So in other words, if a clean out is not done properly, the expected number of days for the stimulation jumps up significantly. And we had planned here for 2 days, but our average is showing 5 days if the clean out is not proper. So the recommended solution therefore goes back to the job planning that Mark was discussing, and specifically on the clean out side, plan to make 1 extra trip. So if the well is clean after 1 run, do 1 extra run, gauge the hole and make sure it really is clean. If you clean out in 2 runs, do again 1 extra trip and so forth. This adds 1 day to the clean out, but it significantly reduces both the job time and the job time variability for the stimulation portion. And even though the expected number nowadays jumps up to 7 from the 6 days on the kind of my on paper example here, there's a very large probability that the job time spent per well will be close to this estimate. And this now enables a manufacturing approach to restimulation. So let's look at the economics one more time. We have our on paper budget. If proper job planning and well prep is not done the way we had gone through in this webinar and in terms of our recommendations, then the average cost tends to be quite a bit higher than our planned budget. And this is our actual average cost numbers when there's been issues on the clean out side. But if we do take these steps up front, the actual cost is only slightly higher than our on paper budget example, and we can now have a high degree of confidence in this number. So this becomes our new budget number for budgeting purposes. And let's address one more point as well, because as Mark discussed, Ranger is doing a good job at logging data for all operations, and we're doing this in order to do continuous operation optimization. So if we can improve time efficiency by just 15%, our expected cost per well is now the same as the on paper example, but now with a high degree of confidence. So to sum up the economics of this, I mean, I think reducing operational risk, if we go back to our 100 well example here, reducing operational risk and job time variability, that is key to realizing the full economic potential of restimulation programs. And proper job planning is then again key to making this happen. So going back where we started with 300 wells that were narrowed down to 100 restimulation candidates, using our own job data, if we assume one rig is going to go out and start treating wells, the amount of wells one rig can restimulate per well jumps significantly up if we do the proper job planning and the well prep that we have discussed. And if we also can implement continuous improvement and just a 15% time improvement, we will shave off a whole year when it comes to the amount of time this project would take. And obviously from a return standpoint, I mean, it all makes the more sense when we're comparing the NPV for the 3 scenarios. So with that, I will conclude the presentation, and then I will turn it back over to Eric for poll results and Q&A.
Thank you, Ivan and Mark, for that great information. And thanks everyone for staying tuned. This wraps up our presentation of compounding returns with manufacturing style restimulation. We did receive some questions during the presentation, and we'll take some time answering them shortly. But first, I just wanted to quickly show you the poll results. There you go. For the question, how do you measure financial return on a restimulation? We see a majority of the votes went to time to pay out and break even. And for the second question, what is your biggest concern when considering a restimulation program? The majority of the votes went to uncertainty around production uplift. All right, now to the questions. If you have a question and still have not submitted one, please do so, and we'll go ahead and answer them in order. This one's for Ivan. The downhole pressure data can be pretty valuable. If you can really get it down to the cluster or individual perf level, will there be any extra costs associated with this?
Yeah, that's a good question. So I think when we started running the tool, the data portion of this was something we initially had as an add-on service. So if our clients were not paying for that, then we wouldn't run the gauges. And we found out that was a very stupid idea, because the data we get out is like you mentioned in the question, it's extremely valuable. It teaches us so much about the effectiveness of the stimulation and the effectiveness of the original completion, and also we can use the data to find future refrac candidates. So we learned fairly quickly that this needed to be a standard part of the tool and something that we don't charge for. And so the short answer is, I mean, it doesn't matter if you're treating individual clusters or individual stages or what you do. The data costs the same; it costs zero. But obviously, we do recommend to focus your energy as much as possible. If you have, as an example, if you have a 10-stage completion with 3 clusters per stage, it's a good idea to try to maybe, instead of treating each of the 10 stages, maybe even try to break it down to the cluster level, because with the data, you really learn so much about what's going on downhole and also how effective your original completion was.
All right, thank you, Ivan. This one's for Mark. How does Ranger perform their operations in a safe manner?
Yep, thanks, Eric. So we didn't touch on it too much in this webinar, but Ranger's got an award-winning, very robust HSE management system and a very highly credentialed HSE team of professionals, as well as a very engaged operational leadership that owns our safety performance. Our HSE management system is composed of 36 elements and 6 core elements that are supported by the Ranger Live EQHSE app that we did touch on earlier. So again, that provides all of the tools that our operational teams need to their fingertips. Their policies, SOPs, a JSA or daily work plan, equipment inspections, any customer specific resources that they need to have access to. They each have a unique employee profile with their training records and history. They can access equipment asset profiles with its maintenance history as well. They also use the system to conduct daily tailgate safety meetings, weekly and monthly virtual safety meetings with their broader team. They submit all their observations through this tool, safety alerts, stop work authority, and continuous improvement. So it's really all housed in that app that we've highly customized. And because as a result of the tools that we've implemented in our QHSE management system and the team, as well as the results that they've delivered, Ranger is an award-winning company. We've been awarded the AESC, Association of Energy Service Companies, Silver Safety Award for both 2018 and 2019 in Group 5, which is the largest group of service companies. The 2020 award should be announced at this summer's meeting coming up. And then we've also received many customer awards as well. So it's, again, it's a very robust, very comprehensive system that we employ and utilize on every job. Thanks, Eric.
Thanks, Mark. This one's another one for you, Mark. Can I get access to my e-rigs and e-ticket job data during or after a job?
Yeah, no, absolutely. So we've got on our website, we have a Ranger Live customer portal where our customers can access both of those apps. We'll provide login credentials. They can click on it, log in, and it'll take them to the cloud where they can monitor their e-rigs real-time data. Or we can provide login credentials for their smartphone app as well. Likewise, for e-ticketing, they can access it and log in through the same portal. Both of them have the ability to create a custom report that can be downloaded and saved or printed in a PDF format. And then you can also download a data set, historical data set in a CSV format if you want to pull it into your own analytical software as well. So we provide a variety of ways to access the data real time during the job, post job, to create daily or weekly post job reports, and to download legacy data sets for future use as well.
Awesome. Thank you, Mark. We got a couple more questions to go here. This one's for Ivan. I'm getting some good results with my bullheading operation. What are the benefits of choosing this method and your tool over bullheading acid?
Yeah, good question. That's something we do get a lot. And I think so we collect production data on all the jobs that we do, and I showed you a little bit earlier kind of some of the learning curve we've been through as well. And combining that also with some of the pressure data that I walked through here, I think we're seeing that the amount of pressure and that it takes to establish injection into the various parts of the lateral varies greatly. And that to me tells the story that we need to have some sort of isolation downhole and selectively treat the lateral, because otherwise the fluid will take path of least resistance. And so what we're seeing, and this is the only way to prove this is empirically, right? So as we're building our database with production data, we're getting more confident on that portion of it, but also talking to our clients that have been doing a bullheading and that are now doing more pinpointed treatments, is that one, the consistency is a lot better in terms of the production uplift, and then the production uplift tends to be higher, but then the decline is a lot shallower than on a lot of the bullheading treatment. So overall, I mean, it becomes a lot more consistent, and the project economics tend to be far better.
Awesome, thank you. Another one for Ivan. On your production uplifts, what is the variance you're seeing on the high point versus low point? And how often do these projects pan out economically?
Yeah, excellent question. Because what I showed here was the average earlier, and the average of all of those wells, that is a 2x increase. But like I showed too, kind of the 2018 and 2000 where numbers were lower than in 2019, and then in 2020 again, and also preface that a little bit too. I mean, a 1.5x increase in production can still be really good, right? If you go from 200 barrels a day to 300 barrels a day, that's still a really good project. So it's not necessarily tied to always to exactly how big of an uplift you get. But what we're seeing when I do a little bit of sensitivity analysis on this, I mean, if you do at least 90% of the wells that we've treated show a sustained production uplift. And then as we've gotten a lot better on the candidate selection side of it, the production uplift risk to a very large extent has been removed, and then it becomes more of a controlling the operational risk that we discussed here today, making sure that we got a good crew out there, making sure that we're doing a proper clean out, and that we don't run into issues that shouldn't have happened. And once we go through that, then we can control the cost, and we make sure that the project doesn't run far over budget, because that really becomes the economic killer at that point. Because like I said, the production uplift we can have, as long as we can get the well treated, we can have a high degree of confidence on that.
Thank you for that, Ivan. That is all the questions that we've got, and thank you for joining, everybody. And we will have the webinar follow-up emails to you guys, and we'll go ahead and send you the video on demand as well. So have a great day, and we'll see you next time. Thank you.
Thank you.